Okay, so, yes.
Is it 7 root 3?
7 root 3, I think that's right. Okay, so start out by factoring, right? And we take out those squares. And then it's 10 plus 2 minus 5 is 7, 7 root 3. Very good. How about the second one? Did you get the second one? What'd you get?
I got 4 root 2y.
4 root 2y. How did you do that? Give me the steps.
So for 200y, I did root 2 times 10 squared times y. And then I took out 10. And then for the other one, I did 3 root 2 squared times 2y.
Okay.
And then I took out the 2. 3 times 2 is 6. So 10 root 2y minus 6 root 2y.
I think that's right. So you factored like that. And then you, I just wanted to make a comment here. You know, factoring a number like 200, sometimes it's easy just to factor that by saying, well, that's 2 times 100, and 100 is 2 times, or is 10 times 10. So, you know, I just kind of listed them all out and then gathered them up, the terms. Okay, and so we have 10 root 2y minus 6 root 2y, and you got 4 root 2y, which is what you said. Okay, very good. Any questions on those? Were you all able to work those pretty well? All right, so that's the kind of simplifying process, and it covers radical addition and subtraction. So now let's look at multiplication, and I think we touched on this and might have even started off with this chart last Friday. Okay, so when we're multiplying radicals, if you look at the rule that we have for exponents, this would be like saying 5 to the 1/2 times 2 to the 1/2 equals 5 times 2 to the 1/2. And so that's where we get this notion where we can take a radical times a radical so long as the index is the same. It has to be, you know, the square root of 2 or the square root of 3 or not square root of 3. It has to be the square root or the cube root or the fourth root. You know, all the indices have to be the same, and we can multiply the radicands, the numbers that are inside the radicals. And so if we have something like square root of 2 times 50 is 100, square root of 100, which is 10. Now, with addition, we put a big emphasis on simplifying first, and then we combined. Here, if we did the simplification, I'll just do it on the board, we can do this like 2 times, square root of 2 times, and then this comes out to 2 times 5 squared, which is going to be then 5 times the square root of 2 times the square root of 2, and so we get 5 times 2 equals 10. So we get exactly the same thing, but it just seems like to me that we're doing kind of work twice. So here's a case with multiplying where you probably don't want to spend too much time simplifying this, because what happens, you find that some of the factors that appear in here and some of the factors that appear in here are the same, and so you get this square root of 2 times the square root of 2 happening in there, and you can just, you know, you have an easy square root. It's the square root of 100, not first taking out the 5, then the 2. Now, multiplying follows all the rules that we've had before. This is the distributive property of multiplication over addition. And so when you have something like this, where you have a number that's multiplied by the whole expression, we just multiply 3 times 2 and then 3 times the square root of 3, and we get 6 plus 3 times the square root of 3. And so if we have radicals in that place, it works exactly the same way, where we just take the square root of 3 times 5, and then the square root of 3 times 3, and so we can see that that's going to be 5 square root of 3 plus the square root of 9, and of course the square root of 9 is 3, so there we have what's simplified. Now, you don't really have to do this, where you say square root of 3 times the square root of 3 is the square root of 9, which is 3. You know that the square root of 3 times the square root of 3 should just be 3, right? So if you have any number, the square root of 41 times the square root of 41 is just 41. So don't, feel like you have to write each and every thing out like this unless there's, a reason, a specific reason that you have for it. But in general, you can just see when you multiply the square root of something by itself, you just get that, you just get the radicand. Okay, so I want to emphasize that this is only for roots that have the same index. So the square root of 2 times the cube root of 3 is already simplified. There's no real helpful operation that you have there. That's done, just the way it is. Okay, so when we have two different factors that are the sum or the difference between numbers, rational and irrational, we do this exactly the way we did with polynomials, where we do this by that acronym FOIL, where you take the first ones, and then you take the outside. So that is going to be 3 times 2 radical 3 minus square root of 3. So square root of 3 times negative 1 is this negative square root of 3. And then we do the inside and the last, and we get 2 times 2 square root of 3 minus 2. And so then once we have that all written out, we can simplify it, and then simplify it a little bit more. So we get 4 plus the square root of 4 plus 3 times the square root of 3. So it works exactly like polynomials. You expand it out, and then you simplify the terms that you're left with. Okay, so I'm going to show you a couple that reduce into something that's really quite convenient and helpful. If we're multiplying these two, and notice the difference between these two is that they have the same numbers in them, but this is the sum of them. This is the difference between the two of them. I'm going to do this by foiling, and so we get the first term is square root of 3 times the square root of 3. Second term is minus 2 times the square root of 3. Third term is 2 plus the square root of 3. And the last term, of course, is negative 4. And so you notice here that these are the additive inverses. One's positive, one's negative. Those cancel out. This is going to be, of course, just 3. And so we have 3 minus 4 is negative 1. So this whole mess turns into negative 1. Okay, to show you something similar to it, here we have the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2. So the first term is square root of 5 times square root of 5. Second term is negative square root of 2 times square root of 5. The third term is the positive version of that, and then we have the negative 2, the square root of 2 times square root of 2. And so that simplifies out, where these inner terms again, this and this, cancel out each other, and so we just have this squared, which is 5, and this squared, which is just 2, and so 5 minus 2 is 3. So this shouldn't be too big of a surprise, because when we have something like a plus b times a minus b, remember this is one of those special forms, we get a squared minus b squared. Okay, so whatever this is gets squared, and whatever this is gets squared, and you take the difference between the two of them, the inner terms cancel out. So the consequence to that is that anytime we have the square root in here, in no matter what form, if they're both or one, so long as we have the sum and the difference, we get them squared, and so we end up without a square root. Okay, it becomes just a regular rational number. Okay, but before we get too far ahead of ourselves, why don't you do these? The first two basically are just two kind of random terms multiplied by each other. The last one has that plus and minus kind of characteristic. And I'll give you a couple minutes to do it, and then I'll ask a few of you to come to the board to do this. All right, so then the solutions to that, you can see, are exactly what I got when I worked them out. Now on this last one, of course, I showed the middle terms, but you don't really have to once you recognize that you have the difference in the sum of those two. Okay, so there's a special word for these two kinds of things. They're called conjugates. And what the conjugate involves is having the difference and the sum with the same first and second numbers. All right, so the conjugate to the square root of 7 plus 3 would be just change the plus to a negative. And then the conjugate to the square root of 6 minus square root of 2 is just square root of 6 plus the square root of 2. So you don't do anything else other than just change that sign. Even if that first term, like if it was negative 6 minus 2, you'd still make it negative 6 plus 2. You don't change both signs. It's important that you only change one sign. And then the last one, it works well with variables, and all you have to do is just literally, all you do is change the sign, the middle sign. So if we were to multiply these out, the long way, I'd get negative 2 there. That negative 3 square root of 7 is canceled out by the 3 times the square root of 7. And then this one worked out term by term, we get 4. And so then this last one, still work that out, it gets 25 minus 9x. Now let me explain this one a little bit more in detail. Okay, actually let me start here. When we take the sum and the difference, what we're really doing is we're just taking the square root of 6 squared and the square root of 2 squared. And so we don't really even have to write these middle terms. We just see 6 minus 2. And so it's that difference between squares. And so here all I'm doing is I'm choosing my two terms, the 5 and the 3 square root of x, and I'm squaring them both. So 5 squared is 25. Then I'm going to notate this as 3 times the square root of x, and make sure that that 3 gets squared as well, so we get this 9x. All right, any questions on this? So, what good is this? The slide that we just had, actually let me go right back to it. This is just multiplication. If we want to multiply 2, let's say we have 2 expressions, we want to multiply it. But it also has a use in simplifying ratios. Okay, so remember when we had a radical in the denominator, we would multiply that radical over itself to rationalize that expression. But if we have something like this where we have the square root of 2 plus 1, we can't just multiply it by 1 over the square, or the square root of 2 over the square root of 2, because that denominator would turn out to be then 2 plus the square root of 2. We wouldn't make any progress doing that. But since we always get now a rational number or an expression that doesn't involve square roots by multiplying by the conjugate, what we're going to do to simplify these is just multiply the ratio by its conjugate like this. And so when we extend that out, the denominator, of course, turns to be the square root of 2 squared minus 1 squared. The numerator is just 1 times whatever we've multiplied, so we get this. Now this turns out to be, of course, 4 minus 1 is going to be, or excuse me, not 4 minus 1, 2 minus 1, because the square root of 2 squared is 2. And so we just get 1 as the denominator, and once we get a denominator of 1, we can just eliminate it and write the square root of 2 minus 1. Now isn't this kind of interesting that the reciprocal of this expression is the conjugate. That's kind of an interesting little feature there. So we have other things that we can do, or we have other things that we can simplify. So here we have 4 over 2 minus the square root of 3. So we'll multiply both the numerator and the denominator by its conjugate, the conjugate of the denominator. And so then when we extend that top, we get 4 times that 2 plus square root of 3. And then we just square both of these. We square the 2 to get 4, and we square the square root of 3, just get plain old 3. And we end up with that over 1 again. Now this is just by not coincidence. I constructed it this way to have a 1 in the denominator. You could very well have any other number, or if it involved variables, you could have a variable down there. But it comes out to something like that, so we get that to be simplified. So think about what this is doing. First off, this is simplifying that ratio, right, of 4 over 2 minus the square root of 3. But it's also how we divide rational or irrational expressions like that. Because isn't that last one the same thing as 4 divided by 2 minus the square root of 3? So now we have a way of doing this. You know, we did the multiplication before, we did addition and subtraction. Now we have a way to do the division. All right, so let's look at another one. What's the conjugate there? Yes?
Square root of 7 minus 1.
-1. Okay, so we're going to multiply that. And then when we multiply it out, we get square root of, or 6 square root of 7 minus 6 over 7 minus 1. And we get 6 square root of 7 minus 6 over 6. Now, what we should do here is, I multiplied out the 6 here to get this. And really what I could have done is I could have waited on multiplying that, because right now what I'm going to do is I'm going to factor out a 6 here. And so what I'm going to get is 6 times square root of 7 minus 1 over 6. And of course the 6's then cancel, and we just get the square root of 7 minus 1. There's a really, really common mistake that people make algebraically, is when you have something like, let's say that turned out to be a little different. Okay, the tendency, or maybe it'll turn out like this, is that you start canceling term-wise, like canceling this or canceling this. And you can't do that. Absolutely cannot do it. When you're dividing, you have to divide each term. So the safe way to do it is to factor out what you want to cancel to make sure that every term is into account, and then cancel. And that's what I did here, where that 6 is factored out, and so the 6's, because you have factors cancel out, don't cancel terms unless you can cancel every single term along the way. So like this one, if you wanted to cancel out the 6's, the right way to do this would be to separate the ratios like this, and then you can cancel out that 6, and you get the square root of 7 minus 1/2. And so that's equivalent to that. But don't just go ahead and cross out the 6's and then say, well, then I got square root of 7 minus 3. That's wrong. And all the forms of that, I see a lot of, and it's one of those things that, is one of those mistakes that you just should really work on eliminating. It's an easy mistake to make, but I see even calculus students still making that particular mistake. So, keep in mind the proper way to do that. Okay, and we'll take one more here. We look at the conjugate here, and that's 9 plus 6, 9 plus the square root of 6. And so what I'm going to do here is I'm going to wait. Now notice here when I multiplied in the 6, and then I factored out the 6 to get that. A good strategy is with this numerator is just to leave this kind of pending, okay? Because what it'll tell you is that if you're lucky enough to get something in the denominator that will factor out and cancel, then you don't have to, do it both ways. So this thing will be 5 over 75, and of course, 5 divided, or 75 divided by 5 is 15, so that reduces to 9 plus the square root of 6 over 15. All right? Okay, time for you to do some more work. Try these, and then I have one more after this, or 2 more problems to do after this. But let's do these, and I'll ask a few of you to come up and solve these. So all 3 of you did these properly, so I'll just illustrate my answers here. So take the conjugate, multiply it out, and so you have something over -1. Now, 2 ways you can handle this. You can just say, okay, this is going to be negative, so you change all the signs in the numerator, and since the denominator will be just a 1 at that point, then you can just eliminate it. Or you can write it backwards, and so -2 plus the square root of 5 is the same thing as the square root of 5 minus 2, and you just have that interior negative sign. A lot of times when you're just calculating along, it's easier to keep track of the negatives when it's between something rather than hanging out the front, that looks like it's part of your equal sign or something like that. So there's no mathematical reason why you need to do that, but just from a tidiness standpoint, if you want, you can do that. Okay, then the second one, very similar to the example that I gave before. There's the conjugate, and notice that the denominator turns out to be exactly the same. That was 75. I delayed multiplying this 5 into this, 9 minus 5 root 6. And it's a good thing I did, because now I see that I have 5 over 75, which reduces to 15. And then this last one, you take the conjugate here, which is square root of 4 plus the square root of 3. Anybody simplify that square root of 4 to 2 first? Okay, it's not really necessary. You can if you like. So we get this, and then simplify it to that. Okay, and as James pointed out, you can rewrite it like this, with a 2 root 5. And that's actually the simplified version. So let me actually write that in here. So we'll say it's 2 root 5 plus the square root of 15. Okay. All right. Now, all of the ones and all of the examples that I had so far involve just a single term in the numerator here. We handle it exactly the same way when there's 2 terms in that numerator. You just basically do the same procedure where you only look at the denominator to determine what conjugate you multiply it by, and so that top expression may or may not simplify on you. So the first thing to work on, of course, is identify which of the establish the conjugate, and then multiply from there. So why don't you go ahead and try these, we'll give you a few minutes, and see how they work out for you. All right, those are both right, and I'll just show you the solution that I came up with. I think I followed exactly step by step the same process. Okay, so exactly the same numbers there. -15, root 15 plus 2 root 5 minus 3 root 3 plus 6. All right, and then for the second one, Okay, so we could have gone a little bit farther on this one here, right? Because we had the 3 radical 2 and the 4 radical 2, which make the 7 radical 2, and then we have the negative 14. And I think here this should be negative 14, right? Because we have 4 times 4 is 16, so we have 2 minus 16.
Yeah.
Okay? All right, so we have that. Now, it is tempting to cancel, so where you're tempted, make sure you're doing it exactly right and factor out the 7. And then we also have a negative 7 here, so I can incorporate that negative just by swapping these two terms like this and get 2 minus the square root of 2, and we're done. Okay, any questions?
Wait a second.
Yes.
So you canceled out the 7s,
Uh-huh.
so that's negative 2, should be like a negative 2 underneath that?
Yeah, you're right. Oops. Like that. Perfect. That's my big 2. Okay. Any questions? Look that over carefully. Now, take a look back on the review sheet, okay? And look at questions number 14 and number 15. So those shouldn't look strange right now, right? Those look like what we've been doing today. All right?